Welcome, geometry students, to the review sheet part 2. This page here we've already had a video on, and so for this video, the review sheet part 2, we are going to focus on these two pages right here, okay? So let's go ahead and start with page 365, numbers 1 through 14, and then we'll work up to page 314, 31 through 34, okay? So with that in mind, let's go ahead and get started with the homework, or the review sheet. Okay, here we go. If you'll look on page 365, for numbers 1 through 4, it says, decide if the transformation is an isometry. If it is, name the transformation. Okay, well remember, in order to have an isometry, the pre-image and the image must be congruent. In other words, they must be identical figures. So on number 1, there's no doubt that these two figures are congruent. So we definitely have an isometry. Now the question is do we have a reflection, a rotation, or a translation? Well, there's no way we can have a translation. There's no way, because the two figures are not facing the same way. In other words, here's your pre-image right here. This figure is not facing the same way as the pre-image. It's definitely, well, it very well could be a reflection, because look, if I draw a line right here down the middle, and if I were to fold the paper, in fact, that's exactly what we have, is a reflection. So if I were to fold the paper right in half, this figure here would fall perfectly on top of this figure here. So for number 1, yes, we have an isometry, and it is a reflection. Okay, reflection. Okay, moving on to number 2. Okay, it is not an isometry. I mean, look guys, there's no way these two figures are congruent. So no, we do not have an isometry. Okay, number 3. Yes, we definitely have an isometry, because the two figures are congruent. So yes, we have an isometry. Now, either we have a translation, a rotation, or a reflection. Well, students, please notice that the two figures are facing the same direction. Here's your pre-image right here. Well, when you look at this figure here, it's not been twisted or turned or rotated or anything. So we have a translation. The ball was moved down, the football was moved down, and then over to the right. So for number 3, we have a translation. Okay, number 4. Yes, we have congruent figures, so we definitely have an isometry, okay? So yes, we have an isometry. Now, notice, here's your pre-image right here. Notice that the scissors, these red scissors, are not facing the same direction as the blue figures, so we definitely don't have a translation, okay? We might have a rotation or a reflection. Well, let's see. Let's draw a line here. If I were to fold this piece of paper right on top of, if I were to fold this piece of paper right here in this red line, would the two scissors fall directly on top of each other? It's really close, to be honest with you, and the more I look at this, I feel like they would, but the book is saying otherwise. Let me turn this for a second. Yeah, it is not a reflection. I'm wrong. Yes, if you were to fold it right here, this right here would not fall directly on this. This is the skinnier side right here. No, it would not. So it is definitely not a reflection. So it's not a translation, and it's not a reflection. So what we're looking at is a rotation, and it was probably rotated around a point right out here, and the string was attached to here, and it was rotated to right here. Okay, it's a rotation, guys. It's not a translation. It's not a reflection. It's a rotation. Alright, moving on to numbers 5, 6, and 7. Now, they want you to trace the figure and draw its reflection in line L. Now, hopefully you're good enough to do that. Hopefully you're able to vision see this well enough in your mind to vision this. But if you were to fold the piece of paper right here in this line right here would be about right here, okay? And then this line here at the other end would be about right here, approximately, okay? So there's the line going across, and then the ball would look something like this. Something like that, okay? Alright, let's go ahead and erase it and see what we got. Yep, there it is, just very similar to what I said. So if you were to flip this, this is what you would get right here. Take a good look at that, students. Make sure you understand that, okay? Alright, if you were to fold this like it was a piece of paper right here, this object here would fall directly on this object here. Okay, moving on. Number 6. Okay, now they want us to reflect this in the line L. So this point here is about this far away. Of course, in your books you can use your compass. Open up your compass to this length here, and then open it up to this length here. They should be the same. And the length from here to here should be the same from here to here. My mouse is doing some weird things again, or my pen is, so I'm going to use the mouse right now. Not sure what it's doing. It's jumping all over the place. Alright, so I'm going to erase this line here. Okay, now the distance from here to here should be the same. Okay, so I'm going to grab this line right here and put it, let's see, it was from here to here. So from here to here, so we should put a point right here. And then the distance from here to the line that we're doing the reflecting right there should be the same here. So we'll put this here and put a point right here. Sketch the figure. So there you go, students. I hope that makes sense. So if you were to reflect this blue figure in the line L, would look like this over here. Alright, okay, let's continue on here, and let's see if I can get the eraser to work here. And here we go. Alright, number 7. Now students, once again, look, the distance from here to here, draw a perpendicular line. That there should be the same distance. And guys, I do apologize, my pen is doing some really weird things. I have no idea what it's doing. And then this line here, that's not a very well drawn line. Hopefully you get the idea of that line there. So what I'm trying to show you here is this line right here will be right here. And that definitely helps you kind of get the circle drawn then after that, okay? Somewhat anyways. So it looks somewhat like that, okay? Decently somewhat like that, okay? So there we go. That's it, guys. I mean, think about it. If you were to fold this piece of paper right here on this line L, this blue figure would fall right on top of the red figure, okay? Alright, moving on to number 8. Okay, students, here we go. Now, we're going to rotate the figure 50 degrees counterclockwise, okay? So we have 2 points we're going to have to rotate. Let's start off with A, okay? Let's go ahead and take our string here, and we're going to draw a line from A to O, okay? There we go. Now we're going to rotate it counterclockwise, so we're going this direction, okay? Counterclockwise, 50 degrees. So put your protractor right here. Put your protractor right here. And you want to rotate this 50 degrees. So here's 90, 45 is here, 50 is about right there. So you would draw a line like this, okay? So do you see what you've done there? You've rotated this way counterclockwise 50 degrees, okay? Now the only thing left for you to do, students, is to make sure that this line here is the same length as this line here, okay? And it should be if it falls right here. Alright, so let me go ahead and get out my eraser here and slide this over. Okay, let me show you this again. Please pay attention, students. So, the distance from here to here should also be the same from here to here. I'm going to kind of guess. It's really hard to do that. But I'm going to say it should be about right there. Looks pretty good, okay? So that point right there is going to be point A. So I took A and I rotated 50 degrees, okay? So, go like this. Get rid of this line. All that we want is point A, nothing else, okay? Just point A. So we rotated point A to here. Okay, now we're going to rotate point B. Let's get our string attached. We're going to take point B and we're going to rotate it 50 degrees counterclockwise, okay? So we put our protractor right here. Here's our protractor. Put it right here in this line. Now 50, here's 90 right here. 45 is about here, so 50 is about right there approximately, okay? So, so I'm going to go ahead and draw this line right here. And that line means I've taken B and I've rotated it 50 degrees. Now the only thing left for me to do, remember, the length from B to O has to be the same length on this red line here. So let me go ahead and erase my protractor here. And here we go. So, let's see, this length here would probably be about, oh, I don't know. Maybe about right here, okay? Probably, that looks pretty good. So the distance from O to B, maybe I went a little too far, maybe closer to about right here. Alright, so there's B right there, so everything else can be erased. Okay, there we go. Now simply draw your line, and you're done. There's point A and point B. So you took this blue line. Now it's not perfect. Is segment AB right here the red segment as long as this one? No, it's a little shorter. It's not perfect, but remember, I don't have anything to measure my lines, so I have to estimate, but hopefully you're getting the steps down, okay? Alright, let's try another one, number 9. Alright, we're going to rotate this triangle 50 degrees counterclockwise. Now, we have 3 points to move. Let's start with E, okay? So we're going to tie a string to E. We're going to rotate it this direction 50 degrees, okay? So we're going to put our protractor right here. That is incorrect. We're going to put our protractor right here. And we're going to measure off 50 degrees. There's 90, 45, so 50 is about right here. So there's my line. I'm going to make it a little longer than I need to. There we go. Alright. Now, so I took my point E and I've rotated it 50 degrees. Okay, now, here's the thing, students. I've got to make sure the distance from O to E is the same on this line here. So it looks like to me it would probably be about right there. I'm going to call that point E. Okay, so I rotated it 50 degrees and the length from here to here is the same as here to here. Okay, so moving on, here we go. Point E is taken care of. We're going to get a lot faster at this the more that we do. Alright, now let's rotate point D. So I'm going to draw my string from D to O. Okay, there it is. Now I'm going to take this line here and I'm going to rotate it counterclockwise 50 degrees. Okay, so put your protractor right here with your protractor in the middle. Okay, and straight up is 90. Half of that's 45, so 50 is about right there. So there's 50 degrees. Draw your line. Draw it good and long so you have enough space, okay? So there you've rotated this line 50 degrees, okay? So now, get out your eraser. We're going to erase the protractor. And of course, you're just going to lift the protractor up off the page. I've got to erase it. Alright, now, remember, this length here has to be the same as this length over here, so I've got to kind of put a point. Now with you can open up your compass, put your needle here, and put your pencil here, and then put your needle here, and mark it off over here, and you'll be just fine. Okay, I'm going to call that point D, okay? Point D, so now go ahead and erase everything else. We don't need anything else. All that we want are our points. Okay, now let's tie a string from C to O like this. There we go. Now we're going to rotate this point here 50 degrees, okay? We're going to rotate it 50 degrees. So let's put our compass, or our protractor, I mean, right here. This will be the middle right here. And let's see, draw our compass or our protractor here like this. Alright, this would be 90, and so half of that would be 45, so 50 is about right here. So there's 50 degrees right here. So I've rotated this counterclockwise 50 degrees. Alright, so here we go. Now remember, students, this length here has to be the same as this length over here, okay? Whatever that would be. So it looks like it'd be about right there, alright? So I'm going to call that point C. And now, students, you're done. You have your 3 points, so you're ready to draw your triangle. So here it is. Now again, it's not going to be perfect. I'm not using a real protractor and a real compass. And no straight edge at all, but there you go. That's a rotation of about 50 degrees, okay? Alright, moving on to the last one in this section, number 10. Now I think this is F, I believe. And this is G. And this is H, okay? And this is point O right here. So we're going to rotate these 50 degrees. Let's start with H. Here's my little line right here. There we go. So put your compass right here. There's the center of it right there. You always put the center of your compass on the letter that you're rotating the object about, okay? So we'll draw our protractor like this. I think I keep keep calling it a compass. Sorry guys, protractor. There's 90, 45's in the middle, so 50's about right there. There we go. Now let's go ahead and erase the protractor. And remember, students, this length here from O to H has to be the same here on this. And that looks pretty good right there. So we're going to call that H right there. Alright, let's take a look now at G right here. Let's draw a string from O to G right here. And we'll put our compass right here on the middle point right here. So, or my protractor, sorry, my protractor. Man, it's really hard to draw this thing. Here's the middle. So there's 90 right there. So 45 is about right there. 50 would be about right there. Alright, so draw that line right there. And let's erase the protractor. So students, remember, this length here should be the same as this length here. Alright, that looks pretty good there. So here's point H, and here's point G right here. G would be about right there. Alright, now let's go ahead and draw our string from point O to F down here. There we go. Alright, now we're going to rotate this counterclockwise, so always put your protractor on, put the center of it on what you're rotating, or the point that you're rotating it about. Okay, so there's 90 right here, 45 is about in the middle, so 50 is about right here. So there's 50 degrees. Okay, let's get rid of the protractor. And now remember, the distance from here to here is the same as the distance from here, or should be from here to about here. And just use your compass and open up your compass and just make sure you have the right length, so we'll call that F right there. Alright. So there we go. Students, there's the triangle that you have rotated 50 degrees, okay? Counterclockwise, alright? Okay, moving on, guys, here we go. Let's take a look at numbers 11 through 14. Okay, we're going to take letter A. We're going to take, let's see, this over here, and we're going to move it. Let's start with 11. We're going to take this figure here, and we're going to move it 0, 3. So we're going to take this point right here, point W, and we're going to move it 0 left So that ordered pair is negative 5, 1, negative 5, 1. No, for negative 6, 1, negative 6, 1. So students, this is really pretty simple. This is W being moved 0 left and right and 3 up. So this ordered pair is negative 6, 1 for W. Do you see any W's here that are negative 6, 1? This one right here. So we know there's no other negative 6 1s right here, so we're good. That's the answer, okay? So number 11 has to be the letter B, okay? Let's try another one. Let's take a look at number 12. Now we're going to take a vertex, a point, and we're going to move it negative 2, positive 5. We may as well let's use another point. Let's use X right here, okay? This is point X, and we're going to move it negative 2, so go over 2. 1, 2, then go up 5. 1, 2, 1, 2, 3, 4, 5. So what is that point called? Negative 2, 4. And that was point X. So we took X and moved it to negative 2, 4. Do you see any X's here that are negative 2, 4? Yep, right here. So we know D is the answer to number 12. D. Moving on now to number 13. Okay, let's take another point. We'll take C. We're going to move it 4 to the right and 1 down. Right here. So that's C, and that ordered pair is 0, 1. Do you see a Z anywhere that's 0, 1? Right here. So we know the answer to number 13 has to be A. Alright? And again, students, if you want to take time and move all 4 points for each one of these problems, you can do that. But it's going to take a lot of time and you don't have to. Okay, number 14, we're going to take a point. We'll take Y. We're going to move it, we'll take this one. We're going to take W, move it 2 to the right. 1, 2, and 4 up. 1, 2, 3, 4. Right here. Well, that's negative 4, 2. Do you see a W anywhere? It's a negative 4, 2. Right there. So you know the answer has to be C. Okay? Alright, not too difficult. Moving on. Okay, now these are going to be interesting, so please pay attention. Alright. All that we're going to be able to do is take what they give us and decide, do we have a trapezoid? And if we do, is it an isosceles trapezoid? Okay, so that's what we need to do, so here we go. First of all, they're telling us AB is parallel to CD. So I'm going to highlight these two sides. They're parallel, okay? Put an arrow on them. Now, angle DCB, this whole angle here, is congruent to angle CDA, this whole angle here. We know that angle DAB, this angle here, is not congruent to CDA. So this angle right here is not congruent to this angle here. Now listen, students, it's important that we know that this angle here, DAB, is not congruent to this angle here. Because if this angle here was congruent to this angle here, then listen to me, we would have to have 90 degrees here and here. Because remember, listen to me, when two lines are parallel, cut by a transversal, the consecutive interior angles have to be supplementary. So if they're equal and they're supplementary, then they both have to be 90. And if they're both 90, and then this is 90, and this is 90, we have a rectangle or a square. Okay? So it's very important that they told us that this angle here is not congruent to this angle here. So yes, we have a trapezoid. We have one set of parallel sides. And remember, we learned a theorem. We have a trapezoid. We have to establish that first, okay? We had a theorem that said if a trapezoid has one pair of congruent base angles, it's isosceles. If you have a trapezoid. So first make sure you have a trapezoid, and if you do, and you have one pair of congruent base angles, then you have an isosceles trapezoid. Please don't forget that, guys. Let me say it again. We learned that if you have a trapezoid, and then you have one pair of congruent base angles, it's an isosceles trapezoid. Alright, moving on to 32. Alright, 32, they tell us that angle DAB, this angle right here, plus ADC, this angle here is 180. Okay? So right away, if this angle here is, and this angle here adds up to 180, do you know that, Mr. Earhart? Well, I just mentioned in the last problem, whenever you have two lines cut by a transversal and their consecutive interior angles are supplementary, then you have parallel lines. So I know these two lines are parallel, and we know that AD is not parallel to BC. So if these two lines are parallel and these two lines over here are not parallel, then we know for sure that we have a trapezoid. Now, do we know for sure that it's isosceles? No, we do not know. We do not know for sure that this angle here is congruent to this angle over here. All that we know is it's a trapezoid. Okay, number 33. AB is parallel to CD, so that's good. Put an arrow there and put an arrow there. And then DAB is congruent to ADC, so DAB is congruent to ADC. That means they're both 90, by the way. I'm going to go ahead and mark them 90 because remember, two parallel lines cut by a transversal, the consecutive interior angles are supplementary. So if they're congruent and supplementary, then they have to be 90. So there we go. So these two angles are 90. And then we know AD is not parallel to BC. So, we know for sure that we have a trapezoid. Okay, students? We know that for sure. But do we know for sure that it's isosceles? No, we don't. Know for sure that it is. In fact, we know for sure that it's not, because if this is 90 and this is 90, and then in order for this to be isosceles, remember the base angles have to be congruent. If this was 92, you guys, think about it, you'd have a rectangle or a square. You'd have 90, 90, 90. So we definitely do not have an isosceles triangle. Excuse me, isosceles trapezoid. No way. We have a trapezoid. Yes, that's true. But there's no way it's isosceles. Remember, if it was, that means this angle here would have to be 90. And if that angle's 90, then this angle up here has to be 92. And we've got a rectangle, okay? And that's not possible. Alright, number 34. AC is congruent to PD. So this diagonal here is congruent to this diagonal here. AB is parallel to CD, so parallel, parallel. And AB is not congruent to CD. Alright? Now it's very important they told us that, because look, as soon as we know that these two sides here are not congruent, AB here is not congruent to this side here, then we know right away that it's impossible to have a parallelogram or a rectangle or a square. Okay, we know we can't have that, because if you have a parallelogram, then this side here is congruent to this side here. If you have a rectangle, this side is congruent to this side. If you have a square, this side is congruent to this side. And they tell us right here, AB is not congruent to CD. So I know that I can't have any of these, and I know this side here is parallel to this side here. So I definitely have a trapezoid. I know that for sure. I have one set of parallel sides. Okay? These sides here are not parallel. So I have a trapezoid now. Is it isosceles? Yes, it is. We learned a theorem, guys. You've got to learn these. We learned a theorem that said if you have an isosceles trapezoid and the diagonals are congruent, then it's isosceles. If a trapezoid has congruent diagonals, then it is isosceles. Okay, so yes, it would be an isosceles trapezoid. I hope this review sheet video has been a help to you. If you have any questions, don't hesitate to call